Sea levels. Sea levels.
Glaciers are melting.
Sea levels are rising almost everywhere on Earth. Beaches are shrinking and coastlines are prepping for trouble, but not in Greenland. Ironically, the same giant ice sheet that can flood the planet could also make parts of Greenland rise out of the ocean by the end of this century. What kind of physics glitch is this? The answer starts with the weight of ice. Greenland is buried under a ridiculous amount of ice. It covers about 80% of the island and spreads across roughly 660,000 square miles, about 3 times the size of Texas. In some places, it's more than a mile thick. At its deepest, it's close to 2 miles. If all of it melted, global sea levels would jump by about 23 feet. Coastal cities like Miami Beach would stop looking like vacation spots and start looking like tourist attractions for divers. And underneath all that ice is actually land. Greenland is not a floating iceberg. It's a real island with mountains, valleys, and rivers. For ages, all that ice has been pressing down on Earth's crust like a giant thumb pushing into soft ground. The crust isn't completely stiff. It sits on top of deeper rock that can slowly change shape over time. The enormous weight of the ice has depressed parts of Greenland's crust, and some bedrock beneath the ice now lies below sea level. Basically, the weight of the ice has made the island sag a bit. But now the island is losing ice relatively fast. Every year, hundreds of billions of tons end up in the ocean. When you lift something heavy off the ground, the Earth starts to push back up to where it was before. Greenland works in a similar way. As the ice melts away, the land underneath starts to bounce back up like a spring that's been squished. Everything with mass has gravity. Planets have it, moons have it, skyscrapers and mountains have it. Your house has it, your coffee mug too, even you and me. But it's so small it's basically impossible to measure. However, Greenland's gravity, even though small, acts like a magnet for the nearby ocean. It pulls the water right toward its shores. That nudge is tiny, but still makes a difference. So when Greenland starts to lose its mass, the gravitational grip will weaken. This makes the water slosh away into the open ocean. Scientists already theorized Greenland would bounce back as it shed ice. But new research shows that some of the rebound might happen faster. The secret could be buried deep underground. Rocks way down could be helping to lift the land, meaning this isn't a slow change that's going to happen ages from now. Some coastlines might keep rising throughout this century, with the biggest shifts likely happening by 2100. In some parts of Greenland, scientists think the land could actually go up by a few feet over the next few generations, which is pretty significant when you consider how things move in geological terms. One reason southeast Greenland stands out is its weird geological history. Millions of years ago, this part of the island passed over the Iceland plume, a deep upswelling of superheated rock. That ancient heat may have left the upper mantle weaker than usual, which could explain why uplift there is happening faster than scientists expected. Underneath all that ice, Greenland has some surprising secrets. Scientists have discovered a huge canyon buried beneath the ice sheet that's 460 miles long, way longer than the Grand Canyon. This ravine is hidden in complete darkness below the frozen surface, but subglacial rivers are still going through it, carrying meltwater out to the Arctic Ocean. Researchers have even pulled up drill cores that show ancient soil and plant remains. It turns out that millions of years ago, this frozen island was actually green and covered in vegetation. The melting ice is even exposing a top-secret ghost town. Back in the 60s, the military built a hidden base powered by a nuclear reactor straight into the ice sheet. The project was called Project Iceworm, which aimed to test whether nuclear missiles could be hidden under the ice. Scientists assumed the ice was stable, but the moving ice quickly crushed and warped the tunnels, forcing them to shut down. They thought it would stay safely buried forever, but now, thanks to the shrinking glacier, those abandoned tunnels and heavy machinery are slowly coming right back up to the surface. The melting ice triggers another cool chain reaction. Moving billions of tons of water off the island shifts the weight across the entire globe. But most of that mass heads towards the equator. When Earth gets heavier around the middle, its rotation slows down. It works kinda like a spinning ice skater stretching their arms out. The entire planet actually takes longer to complete a full spin. Yes, the melting ice is actually making a day longer. The actual shape of the planet changes along with it. Earth is already slightly lumpy rather than a perfect sphere. The sheer mass of the Greenland ice sheet helps warp the crust. As the ice melts and the ground bounces back, the physical geometry of the globe shifts. So not only does it make the day longer, it can actually bend the world out of shape, literally. Back on the surface, the consequences get very local very fast. Greenland's towns are mostly built along the coast, and many depend on fishing. But when the land rises, the water near the shore gets shallower, harbors can turn muddy, ships can get stuck, and towns may need to dredge channels just to keep supplies moving. The coastline also starts changing shape. New rocks and small islands can appear, and routes that used to be safe can suddenly become risky. And the ice sheet itself is anything but quiet. Huge outlet glaciers like Helheim keep pushing toward the ocean, cracking and grinding as they go. When giant slabs break off and crash into the sea, the impact can be strong enough to trigger glacial earthquakes. Those shockwaves travel through the planet, and seismographs thousands of miles away can pick them up. At the same time, meltwater can slip underneath the ice and make the whole glacier slide faster, like a heavy object suddenly hitting a wet floor. Once meltwater starts moving through the cracks in the ice, it can weaken the glacier from above and below at the same time. The shifting landscape can trigger even bigger chaos. In 2023, part of the mountain in East Greenland collapsed into a narrow fjord and launched a wave about 650 feet tall near the impact. The walls of the fjord trapped the water, turning the whole place into a giant sloshing basin. The water sloshed back and forth so violently that the entire planet vibrated for 9 straight days. Another interesting thing is that the snow on top is messing things up for the ice underneath. When it gets warmer, tiny algae start blooming like crazy and turn the snow pink. Locals call it watermelon snow. It might sound cute, but it's a big problem. Bright white snow reflects sunlight really well, but when it turns pink, it starts soaking up heat like a dark shirt on a hot day, which makes it melt way faster. The ice also gets covered with tiny particles like dust, soot, and microbes. Because they are darker than clean ice, they absorb more sunlight and melt little pits into the surface. Millions of these tiny pits can turn the solid surface into something like frozen Swiss cheese. Scientists call them cryoconite holes. They form when dust, soot, microbes, and organic material clump into dark grains that absorb sunlight, melting narrow little shafts that can even host tiny microbial ecosystems inside the ice. And that's what makes Greenland so fascinating. At the start, this looks like a physics glitch. An island losing ice should mean more water and higher seas. But Greenland doesn't play by one simple rule. As the ice shrinks, the land rises, the nearby ocean shifts, and deep rock starts responding too. What looked like a contradiction is really a whole chain reaction hiding inside one frozen island.
Nearly 12,900 years ago, hey, I wasn't around then, but something happened that pushed the northern hemisphere back toward the Ice Age. For years, scientists thought the cause was a huge asteroid, but new research points to something that was here on Earth all along. A volcano hidden beneath ice or underwater that, instead of melting the ice, did the opposite and made Greenland even colder. Scientists call this abrupt deep freeze the younger dryas. Despite how it feels with those unbearable summer heat waves around the world, Earth is still technically in an ice age. Earth's orbit and axis go through all kinds of tilting and wobbling, which is why we swing between colder glacial and warmer interglacial periods. Right now, we're in an interglacial period, named the Holocene. But before civilizations could really grow crops and enjoy summer, they had to endure this unexpected freeze that lasted for about 1,300 years. Evidence from Greenland suggests this change happened within just a few decades. Temperatures dropped by more than 27 degrees Fahrenheit, winds got stronger, and the entire North Atlantic started acting like someone turned the freezer up a few notches. In Europe's sediments, the plant record flipped back to cold climate tundra. That shift even brought back a tough little Arctic flower, dryas, in the middle of Europe, and that's what this sudden, teeth-chattering cold spell was named after. But why the unexpected brrr? The clue comes from deep inside the Greenland ice sheet. All that endless ice is like the Earth's hard drive, with all the events sorted in order. When it snows in Greenland, the snow doesn't really melt away. Instead, more snow just keeps piling up on top of it each year. Over time, all that weight squashes the layers beneath, turning them into ice. This process captures tiny air bubbles that hold bits of the atmosphere. Basically, the frost keeps a snapshot of whatever was happening in the sky at that time. For example, if there was a big forest fire in Canada 5,000 years ago, the smoke and soot would drift over to Greenland and settle on the snow. If a big asteroid impact really happened around then, you'd expect its chemical traces to show up in the ice layers from that time. Now, to access this data, scientists use massive hollow drills. They drill deep into the ice and pull up long cylinders called ice cores. And because Greenland's ice is nearly 2 miles thick, those cores can preserve a ridiculously long climate record, allowing scientists to examine ice that's over 100,000 years old. By examining ice cores from that period, researchers found a sudden spike in platinum. This element is super rare near Earth's surface, but it's much more common in meteorites and asteroids. That's why theories were pointing to something huge from space. But how could an asteroid cause climate change? Well, basically, it works like this. Let's say a giant rock slams into an ice sheet. The impact blasts dust, ash, and all kinds of particles high into the sky, way above the clouds. Big booms can cause massive fires, adding even more smoke. Now the planet is wrapped in a dusty, smoky layer that blocks part of the sun's energy. The thing with ice is, when it doesn't melt, it spreads and reflects sunlight back into space, which makes things colder again. That loop is called the ice albedo feedback. Sounds like a cool theory for the younger dryas. And just to make it even more tempting, Greenland also seems like it might be hiding the actual crater. Radar surveys beneath the Hiawatha Glacier revealed a round structure about 19 miles wide. Scientists were wondering if this was the one that caused the younger dryas, but dating showed it was about 58 million years too old to be the culprit. Also, a platinum spike doesn't automatically mean a meteor. Platinum from space usually comes with a supporting buddy metal called iridium. If you find one, you should find the other. But when scientists analyzed the Greenland ice, iridium was missing. So the chemistry didn't really point to a meteor. It looked more like volcanic magma from the North Atlantic. Then there's the shape of the platinum signal. It drags on for multiple years, not one sharp boom layer. That's more like something steadily feeding the atmosphere, not one big explosive impact. So, if platinum isn't pointing to a fresh impact, the next question is simple. What on Earth can put platinum into the sky and also cool the planet? The answer is a volcano. The kind they're talking about could have been in the North Atlantic region, possibly in Iceland, and it may not have even been fully on land. It could have erupted under thick ice, or underwater. Here's the difference. When a volcano blows its top in the open air, we get ash clouds and oozing lava rivers. But under the ice, magma hits meltwater, flashes it into steam, and can explode into fine ash and gas. Underwater, powerful eruptions can also fragment magma and push material upward. In both cases, the real trouble isn't the molten rock, it's the gas. Hey, I can relate. Now, big eruptions like these spit out massive amounts of sulfur dioxide. If that gas gets high enough, like miles above the clouds, it spreads out and mixes with water vapor to create sulfate aerosols. These are basically microscopic droplets of sulfuric acid. Individually, they're invisible, but get billions of them floating together and they act like a planetary shade. From space, Earth actually looks shinier because those droplets are reflecting sunlight. But down here on the ground, it's like looking at the sun through a thin, silvery veil. You don't need total darkness to freeze the world, you just need to dim the sun a little. Summers stop being truly warm, and snow survives into July. That leftover snow compacts into ice, which reflects even more sunlight. It's the same kind of feedback loop as the one triggered by an asteroid, except in that case, the sun is blocked by dust, while here, it's reflected back into space. Something similar happened quite recently. In 1991, Mount Pinatubo in the Philippines unloaded about 20 million tons of sulfur dioxide into the stratosphere. It wrapped Earth in a thin veil, and global temperatures dipped by about 1 degree Fahrenheit for about 2 years. Just imagine the scale of the eruption if Greenland's temperatures had dropped by more than 27 degrees Fahrenheit and stayed that cold for 1,200 years. But here's an interesting question. Could it be neither? Not a climate-changing asteroid, nor a hidden volcano. There's a third suspect that's much quieter but just as dangerous: fresh water. One leading theory is that the world warmed up and a massive glacial lake in North America, often linked to Lake Agassiz, suddenly drained or rerouted, dumping an absurd amount, like quadrillions of gallons, of fresh water into the North Atlantic system. That fresh water diluted the surface ocean in regions where dense, salty water normally sinks and helps drive large-scale Atlantic circulation. When that sinking weakens, the overall circulation slows down and less ocean heat reaches the North Atlantic. With that system disrupted, the Northern Hemisphere could cool extremely fast on a climate timescale, within years to decades rather than centuries. In that version, the platinum spike could be a coincidence, a volcanic burp during the freeze, not the trigger. And in the end, if the volcano was the cause of the endless winter, could this happen again in our time? Absolutely. The North Atlantic region is still geologically active. Iceland erupts regularly, and the volcanic systems along the Mid-Atlantic Ridge are very much alive. But it wouldn't be a jump scare out of nowhere. Even volcanoes buried under the ice usually give warnings, like earthquakes. If heat builds down there, it can melt large volumes of ice from below before anyone sees ash in the sky. On the other hand, it wouldn't need to be a planet-destroying eruption. A moderate blast that injects sulfur high into the stratosphere could dim sunlight for a couple of years, just like Pinatubo did. That does not mean a new ice age will start the day after. Today's climate background is very different from 12,800 years ago. But the mechanism is real. The atmosphere can still be nudged, and sometimes all it takes is a hidden eruption.
Scientists just drilled through about 1,700 feet of Antarctic ice and pulled up a record-breaking core. It's a 750-foot tube that reaches back about 23 million years. The core showed that this part of West Antarctica had been an open ocean back then. That means the ice sheet had collapsed before. And if it sinks again, global sea levels could rise enough to turn coastal cities into aquariums and rewrite the map of the world. To learn more, an international research team set up camp at a spot called Crary Ice Rise. It's like a giant frozen raft stuck to Antarctica, caught on rocky bumps on the seafloor. Those bumps act like a brake, helping hold back the inland ice. But warmer ocean water is starting to melt the raft from below. If the ice thins and lifts off those rocks, the brakes are gone, and the inland ice is going straight into the ocean. That is why scientists decided to drill here. Drilling a straight hole through a third of a mile of ice sounds impossible. It can't be done with a regular drill. Instead, the crew had to use a custom hot water drill. It's basically a superheated pressure washer, It shoots near boiling water straight down to melt a vertical tunnel about 1 foot wide. The problem is, the ice tries to heal the hole shut. The continent itself is saying, nope. If the hot water stops flowing for even a little bit, the tunnel starts freezing again and the hole begins to close. And since they were in the middle of a frozen wasteland, they had to set up a small camp of tents with its own power supply. The nearest station is about 450 miles away, so any serious breakdown could mess with the whole project. For comparison, the space station is about 250 miles above Earth's surface. So this expedition had to be planned almost like a space mission. Granted, the ISS is still harder to reach, but you get the point. If the camp lost power, the researchers would have to fix it fast, within 1 or 2 days, or the hole could freeze shut completely. You might already know that ice can trap ancient microbes and particles from the air. Snow falls, freezes, and stacks up in layers. Each layer traps whatever was floating around at the time. Stuff like dust or gases, even tiny organisms. That's how scientists read the past. Those stacked layers are called ice cores. But the researchers weren't after the ice. What scientists recovered there is a sediment core. Instead of frozen snow, it's a long tube of mud and rock drilled from the ocean floor under the ice. Think of it like this. Ice cores record what was in the air. Sediment cores record what was happening in the ocean. Everything floating in the water eventually sinks. When a massive ceiling of thick ice completely covers the ocean, the water below goes pitch black. Without sunlight, there's no way for plants to grow. The only stuff sinking to the seafloor is heavily crushed rock, physically scraped off the land by the moving ice above. When the climate warms, the ice pulls back and sunlight brings back life. The seafloor starts building the open water layer again. Over time, you get a repeating pattern. Gritty rock when it's iced over, pale shell-packed mud when it isn't. It's like Earth creating a barcode for scientists to find. When the drilling crew finally cracked open their giant tube of dirt, the mud was filled with marine fossils, the physical remains of ancient ocean bugs. And those specific bugs absolutely require sunlight to survive. Their entire food chain runs on big algae blooms at the ocean surface, so finding them is big proof that under warmer conditions, the ice pulled back completely. The total disappearance is the scary part about how West Antarctica behaves. The ice doesn't simply melt away inch by inch in a slow, predictable way. It has a built-in tipping point. Finding those deep-sea fossils suggests that once the ocean gets warm enough to lift the ice and release that rocky parking brake, the whole frozen raft can suffer a full system failure. It might basically vacate the premises, and that kind of collapse is what makes scientists nervous. Researchers call this one-way behavior hysteresis. This is Billy. He's sitting on a sled at the top of a snowy hill. The sled is pointed downhill, but Billy isn't moving yet because the snow is still holding him in place. Then someone gives the sled a tiny push. At first, it's just a slow creep. But once the runners start sliding, gravity takes over and the sled picks up speed on its own. The key part is that even if the person who pushed Billy instantly regrets it, the sled won't stop. Huge ice sheets can work the same way. Push the planet past a certain temperature line and the retreat can keep going on its own. Even if temperatures drop again centuries later, the melting doesn't automatically slam on the brakes. So scientists are trying to figure out how much warmer it has to get for West Antarctica to enter that locked-in mode. One estimate says the danger zone starts at about 3.6 degrees Fahrenheit above the global average temperature in the mid-1800s. They still can't say that's the exact flip point or give a clean countdown. That's what this core is meant to help confirm. But the ice isn't only getting hit from the outside by warmer water. Parts of Antarctica get heat from below too. Near the Ross Ice Shelf sits Ross Island, and on it, an active volcano. It's called Mount Erebus. It rises about 12,400 feet above sea level, and it's the southernmost active volcano on Earth. But the cool part is that inside its summit crater is a persistent lava lake, an actual glowing pool of molten rock that's been churning for decades. That's not normal. Only a handful of volcanoes on Earth maintain long-lived lava lakes. Erebus does it while surrounded by one of the coldest environments on the planet. Antarctica can be brutally cold at the surface, but Mount Erebus is powered by heat from deep inside the Earth. That heat doesn't care if the air above is negative 40 degrees Fahrenheit. Magma rises because it's hot and buoyant. As long as fresh magma keeps feeding the crater and gas keeps escaping, the lava lake can stay molten. Erebus also creates something you rarely see elsewhere: ice towers built by a volcano. Hot gases escape through cracks, hitting the freezing air and instantly solidify into tall, hollow chimneys of ice. Some of the caves inside those towers can be surprisingly warm compared to the outside air, creating strange little pockets where microbial life can survive in the dark. Another cool thing about this region is the miles of subglacial lakes. Some are the size of small cities. Pressure helps keep them liquid and heat from below keeps them from freezing. A bunch of them connect through hidden channels, so they fill and drain like an underground plumbing system. Satellites can even catch the ice above rising and falling as the water moves. Erebus matters because it proves West Antarctica can get heat from below. That heat can melt the ice at the base and create water underneath. Those buried lakes matter because that water acts like lubrication. Less friction means the ice can slide faster. And when lakes fill and drain, that slippery layer can shift around suddenly. When grip and support both weaken at the same time, that sled doesn't need much of a push. There's no doomsday clock on the wall counting down to some dramatic end of the world. Even if West Antarctica starts sliding into the ocean, it wouldn't happen overnight. Coastlines would shift inch by inch, one storm at a time, with decades in between. Cities wouldn't vanish with a single wave. We'd have to do a lot of redesigning and moving. And centuries from now, if parts of today's coastline sit underwater, future divers might swim past the tops of skyscrapers the way we dive through ancient shipwrecks.
Ooh, mysterious mountain ranges hidden under thousands of tons of ice. Bizarre, transparent creatures with see-through skin, singing snow plains. Antarctica has its own terrifying secrets. And now, a mysterious ice hole the size of Switzerland that keeps popping open. And scientists have finally figured out why. This hole, called the dryas Polynya, was first spotted in 1974 and 1976 in the Weddell Sea. Since then, it's been kind of playing hard to get. Sometimes it appears, sometimes it disappears for years. And when it does show up, it mysteriously changes size. For decades, researchers were trying to figure out what makes it form. Then, in 2016 and 2017, the Polynya went absolutely massive, more than 30,000 square miles. The hole stuck around for several weeks during winters. It was the first time since the 1970s that the Weddell Sea had such a huge, long-lasting Polynya. Here's the deal with Antarctic sea ice. In summer, the ice is at its smallest, around 1 million square miles. Yeah, that's considered small. By winter, it spreads to a whopping 7 million square miles, covering about 4% of Earth's surface in weird white tiles. Most of this ice grows during the weeks-long polar night on the floating ice shelves around the continent. These holes in the ice, called polynyas, usually form when strong winds from inland push the ice tiles apart. That same cold wind also freezes more seawater inside the hole, adding extra chunks to the ice sheet. But the dryas Polynya isn't near the coast, where those winds normally help make holes. Out in the open ocean, holes like this are rare. Add in the fact that ice across the Southern Ocean has been shrinking. No wonder scientists are left bewildered. What exact conditions are creating this stubborn giant ice hole? To crack the mystery, the scientists dove into a mountain of data: satellites, floating sensors, even info from tagged marine animals. Plus, they had years of past observations from other researchers, and they found something unusual. In 2016 and 2017, the Weddell Sea's circular ocean current, called the Weddell Gyre, was stronger than usual. That extra punch made it easier for salty, warmer water from deep below to reach the surface. The Maud Rise Polynya sits above an underwater mountain called Maud Rise. During those big Polynya years, the stronger current caused salt to gather around this submerged peak. On the surface, the wind whipped over the ice, creating a corkscrew effect. It literally pulled that salty water up from below. The extra salt lowered the freezing point of the surface water, allowing the Maud Rise Polynya to form and stick around. Polynyas are really important for the planet. The dense salty water formed in these holes can travel huge distances, spreading across the global ocean and affecting climates everywhere. But these magnificent holes aren't the only cool and mysterious phenomena Antarctica is famous for. How about underground lakes? Or shall I say under-ice lakes? Because there are entire lakes hidden under Antarctica's thick ice. Scientists first found them back in 1970 using radar, and now they think there are around 400 lakes tucked under around 2 miles of ice in the explored areas. These lakes likely formed after Antarctica broke off from Gondwanaland, the ancient supercontinent. Surprisingly, the water in the lakes doesn't freeze because the ice above presses down too hard. Hey, it's physics, bro! The biggest of them all is Lake Vostok, discovered in the 1990s. It sits a bit more than 2 miles below the ice. Scientists have drilled down to take samples, and the water they pulled up was about 26 degrees Fahrenheit, even though the lake had been trapped under ice for over 20 million years. There's also Lake Williams. In 2014, scientists made a lit discovery there. They found a thriving colony of microorganisms nearly a mile under the ice. Those tiny creatures never saw sunlight or fresh air. Instead, they used methane and ammonium as energy to grow. Another marvel hides in plain sight in the McMurdo Dry Valley. It's a waterfall that looks like something straight out of a horror movie. Bright crimson water, like blood gushing from a wound in the ice, pours down 5 stories from Taylor Glacier into Lake Bonny. Ooh, spooky. But there's actually a scientific reason behind it. The water that feeds Blood Falls used to be part of a salty lake. Now, it's completely cut off from the atmosphere because glaciers formed on top of it. Trapped more than 1,300 feet underground, the water has become super salty, 3 times saltier than seawater, and it can't freeze. This underground water is also packed with iron and completely lacks oxygen in sunlight. When it slowly seeps through a crack in the glacier and hits the open air, the iron oxidizes, basically rusts, and turns the water that eerie dark red. With such creepy landscapes, Antarctica might look like a frozen wasteland. Freezing cold, almost no rain, and winds that could knock you off your feet. The coldest Earth's temperatures ever was recorded there, minus 128.6 degrees Fahrenheit. And still, Antarctica is actually home to some seriously bizarre wildlife. For the longest time, scientists thought nothing could survive under all that ice. Turns out, they were very wrong. There are all sorts of creatures that have adapted to the brutal environment. Tiny microbes, crustaceans, colossal squid, and spiders so big their legs could cover a dinner plate. Giant worms with shiny golden bristles and huge sharp-toothed jaws also lurk under the ice. And then there's the ice fish, a completely see-through fish with huge eyes and organs you can literally see through its skin. These fish have built-in antifreeze proteins to survive the freezing waters, and they can't live anywhere warmer. Even stranger, they don't have hemoglobin, the protein that makes our blood red. In other words, they survive without the stuff that literally keeps most animals alive. But Antarctica wasn't always the frozen desert we know today. Millions of years ago, before the Ice Age, It was actually warm, lush, and full of life, maybe even home to ancient civilizations. Hard to imagine, huh? Scientists figured this out after finding fossilized wood, tropical tree remains, and leaf impressions, all pointing to the existence of rainforests. On top of that, they've uncovered fossils of marine animals, birds, and dinosaurs from the Cretaceous period. Even tiny creatures left their mark. Fossilized beetle wings from 14 to 20 million years ago, single-cell fossils, and, astonishingly, 50-million-year-old sperm cells preserved in the egg case of an extinct worm. So now, it probably won't shock you when I tell you that beneath Antarctica's thick ice sheets, there's a massive hidden mountain range. The Gamburtsi Mountains stretch for 745 miles and rise to almost 10,000 feet, about the third the height of Mount Everest. And all this is buried under between 6,500 to 13,100 feet of ice. The mountains were discovered in 1958. Scientists noted a thin patch of ice and some weird gravity readings while crossing the continent. Even though no one has ever seen those mountains directly, researchers use radar to map their shape and gravitational and magnetic readings to study them all the way to their base. Perhaps the craziest part is that the Gamburtsis are around 1 billion years old. So, in theory, they should have eroded away long ago. How they're still standing is a mystery. Most scientists think a frozen mantle beneath the ice might be protecting them from erosion, keeping this ancient range intact. And finally, Antarctica has its own soundtrack. The Ross Ice Shelf, the continent's largest ice shelf, is several hundred feet thick and spreads over 193,000 square miles, roughly the size of France. And scientists have recently discovered that this massive ice slab actually sings. The eerie melody comes from wind blowing over snow dunes, which creates vibrations in the ice and a nearly continuous seismic hum. You can't hear it with your ears, but seismic sensors pick up the mournful tune. In fact, it was discovered by accident. Scientists just installed special sensors to monitor other ice behaviors. Now, even cooler, the song changes depending on what's happening on the ice. Melting, storms, and shifting snow all tweak the vibrations. Researchers are now using this haunting melody as a kind of early warning system. They listen to it in real time to track the ice shelf stability and potential collapse. Ice piracy is like Pirates of the Caribbean, but you gotta swap those tropical seas for icy, freezing waters. And the captain here isn't Jack Sparrow, but a massive glacier in Antarctica. Meet the Polar East Glacier. Its calm, sparkling surface might look innocent, but don't be mistaken, it is a pirate, and a pretty skilled one too. Instead of gold, it's been stealing ice from its neighbors at record speed, and scientists can't believe what they're seeing. So, what exactly is ice piracy? Arr! This is a strange kind of glacier movement, where one glacier starts taking ice from another nearby. Instead of minding its own business and slowly sliding toward the sea, it suddenly changes course and begins pulling ice that used to belong to its neighbor. The pirate glacier speeds up, the victim slows down. The problem is that the balance of ice in the region might get completely thrown off. This isn't brand new information though. Scientists have known about this quirky behavior for quite a while. But they used to think that this process took hundreds, maybe even thousands of years. Now, something really strange is happening in Antarctica. We're seeing, for the first time ever, a glacier pirate in action, and it's moving much, much faster than anyone expected. It all started when researchers from the University of Leeds began looking at satellite images taken between 2005 and 2022. They wanted to analyze the rates of flow from 8 ice streams in West Antarctica. And yes, glaciers do move. Think of them as huge piles of snow that have turned into solid ice over time. This ice slowly changes shape, shifts, and moves. That's why glaciers are often called rivers of ice, because they flow, for real. Gravity is what makes it happen. The ice slowly slides and deforms under its own weight, thanks to the pull of gravity. And when it comes to glacial movements, they can either advance or retreat. If more snow and ice build up and melt away, break off, or evaporate, a glacier will advance. But if it loses more than it gains, it will retreat. Oh, and glaciers also move at different speeds, depending on things like the slope of the land beneath them. But if that flow starts speeding up, well, that's bad news for coastal communities all over the world, because that means more ice is moving from land into the ocean, which contributes to Antarctic ice loss and, eventually, sea level rise. Now, back to the recent ice research in Antarctica. The team calculated ice velocity using a tracking technique that measures how visible features, like cracks or rifts on the ice surface, shift over time. And they found that 7 of those 8 Antarctic glaciers had sped up. On average, they've doubled their speed since 2005. Given the impacts of how Antarctica's climate is changing, warming up more and more each year, this doesn't really come as a surprise. But here's something strange. One glacier, just one, slowed down. We're talking about the Polar West Glacier. It slowed by about 10% over the study period. But how can a massive chunk of ice just hit the brakes, so to speak? To figure that out, researchers looked at its surroundings, and there it was, the culprit, the Polar East Glacier. Experts think Polar West slowed down because it's flowing toward its pirate neighbor, Captain Whitebeard, Polar East. That one's moving much faster. In fact, it's one of the fastest glaciers in the area. Its speed has been increasing by about 105 feet every year over the study period. Okay, that might sound slow, even for a tortoise. But for a glacier, that's disturbingly fast. Polar East is the Usain Bolt of ice chunks, and that's not even the most impressive part. The strange thing is that it changed its flow direction. Instead of moving straight ahead like it used to, it's now turning towards its neighbor, Polar West, and pulling ice from it. Scientists think this is happening because the ice at the point where the glacier meets the ocean is melting faster than before. That glacier melting makes the ice thinner, and as it thins, it changes the way the ice upstream flows. So now, instead of feeding both glaciers evenly, more of that ice is being funneled onto Polar East. In short, Polar East is speeding up and changing its course. So now it's pulling or stealing ice from its slower neighbor. And just like that, this mysterious glacier in Antarctica became a real ice pirate. Okay, this whole ice piracy thing isn't that weird. It's part of how glaciers normally behave. Slow, dramatic, and occasionally a little mischievous. What really blows scientists' minds is how fast it's happening. They used to think this was a super slow process, something that would take hundreds or even thousands of years. But this one is taking place in just 18 years. And this is a huge satellite discovery in Antarctica. Scientists were only able to spot it thanks to the Copernicus Sentinel-1 mission, a pair of European satellites that use radar to keep an eye on Earth's surface. They can track changes in ice, land, and ocean with incredible precision and coverage, making them perfect for studying how the polar regions are changing. Because here's the thing, keeping an eye on the coldest parts of our planet is becoming essential for our future. And this particular part of Antarctica, where both the Polar West and East glaciers are located, is thinning faster than anywhere else. Its glaciers are retreating at record speed. The grounding line, the point where the glacier stops resting on land and starts floating on the sea, is moving backward. When that happens, the ice sheet slides into the ocean even faster. But scientists say glaciers aren't just melting, they're reshaping themselves in completely new ways. And that's exactly what's happening with the Polar East Glacier. Seeing a pirate glacier in action firsthand has once again changed how scientists look at things. The new data on ice piracy shows something they've never seen before. Glaciers and floating ice shelves are interacting in new and surprising ways. So, more and more, experts need to rethink how these icy giants behave as the world warms up. And that's a big deal, because they play a significant role in how fast sea levels rise this century. In fact, Antarctica's glaciers are one of the biggest reasons our oceans are swelling. The continent is losing about 135 billion tons of ice every year. It's like dumping tens of billions of Olympic-sized pools of water into the ocean annually. If all of its ice melted, sea levels would rise by about 190 feet. That kind of rise would flood much of Florida and huge areas of the Netherlands and Bangladesh, for example. Many small island nations would completely vanish beneath the waves. Now, you might be asking yourself, what's hiding beneath all of Antarctica's ice? Well, it might look flat from above, but underneath that mile-thick layer of ice lies a whole landscape of steep mountains and deep valleys, crossed by winding rivers. Those hidden rivers could play a crucial role in how the ice sheet reacts to all this unusual warmth. Scientists now predict that as Antarctica's ice sheet keeps melting and thinning over the next few decades, those subglacial rivers will grow, overflow, and shift into new paths. This could make some of the biggest glaciers near the coast start to break apart faster, and that would make sea levels rise more quickly. So that's why understanding these changing dynamics and glacier movement, like our icy pirate, is so important. Every new discovery helps scientists figure out what's really driving Antarctica's glaciers and how they are responding to a warming world. The more we learn about these frozen giants, the better we can predict what might happen next, and how changes down in Antarctica could ripple across the entire planet.
Put on your woolen hats, find the warmest mittens, and go buy the thickest blankets. The next ice age might be just around the corner. And the trigger is much more shocking than anyone might have expected. What's even worse? We have no control over our bitterly cold future. Earth's climate has been on a wild ride for millions of years. It's been warming up, freezing over into ice ages, then heating up again to the more normal temperatures we know today. These cycles, called quaternary ice ages, are part of a much longer pattern of global freezing and thawing. For a long time, scientists thought Earth's orbit around the Sun had something to do with triggering ice ages, but figuring out exactly how was tricky. Well, new research has finally connected the dots. It shows how tiny changes in Earth's tilt, wobble, and orbit mess with the growth and melting of huge ice sheets. This is a pretty big deal because it helps scientists understand not just what happened in the past, but also what might happen to our climate in the future. Even small shifts in how Earth moves through space can have huge effects over thousands of years. These changes control how much sunlight different parts of the planet get, which affects how ice sheets grow and shrink. Earth doesn't orbit the Sun in a perfect circle. It actually follows a slightly oval-shaped path. This phenomenon is called orbital eccentricity. Since the Sun isn't sitting right in the center of this oval, Earth's distance from it changes throughout the year. Plus, the oval itself slowly shifts position in space over time, which is called orbital precession. On top of that, Earth's tilt, aka obliquity, also changes slightly as our planet moves around the Sun. Scientists have known for a while that these orbital quirks impact our planet's climate, causing cycles of warming and cooling. As different parts of Earth's orbit shift, they change how sunlight is distributed across the planet, influencing seasons and ice ages. These Milankovitch cycles happen roughly every 20,000, 40,000, 100,000, and even 400,000 years. The difficult part is to figure out how each of these orbital changes affects climate shifts. Earth's climate is a complicated system, with tons of factors influencing it at the same time. Modeling all these processes is no easy task. It needs huge computing power and a deep understanding of each factor's role in shaping our planet's past and future climate. There are two cycles that are super close to each other in timing. Precession, which happens every 21,000 years, and the second harmonic of obliquity that happens at 20,500 years. But even though they're so close, no one has been able to directly connect either of these cycles to the end of an ice age. On top of that, for the past 800,000 years, ice ages have ended every 100,000 years, and scientists still haven't figured out what causes this pattern. To get to the bottom of it, researchers turn to the deep sea. They studied changes in oxygen isotope ratios found in the tiny, fossilized shells of marine creatures. These tiny creatures live in the ocean, and their exoskeletons preserve clues about past climate, specifically changes in ice sheets. This allowed the researchers to track the beginning and end of ice ages over the past 800,000 years. By comparing the changes in the ice sheets with Earth's orbital changes, they found an incredible pattern. The key moments when Earth moved between ice ages and warmer periods were perfectly lined up with specific relationships between precession and obliquity. It turns out that the end of an ice age, called deglaciation, is closely linked to the way precession and obliquity align. But it's obliquity alone that seems to trigger the start of an ice age. This discovery is the key to understanding the 100,000-year cycle of ice ages. The researchers say it was always there, just waiting to be noticed. Before the discovery, people thought the timing of ice ages was more random. But this new study shows there's a clear, predictable pattern. This means we might actually be able to predict when ice ages will happen in the future. Right now, Earth's tilt is slowly decreasing, and in about 11,000 years, it'll hit its lowest point. Based on the team's calculation, the next ice age is expected to begin before then. At the same time, according to the latest reports, humans have already started pushing Earth's climate off its natural path by releasing greenhouse gases. Another thing scientists are warning about is a massive shift that's happening in the Atlantic Ocean, and it could drastically change the world's climate. The Atlantic Meridional Overturning Circulation is a system of ocean currents that moves warm and cold water around the planet. And right now, it is showing signs of weakening. What will happen if it collapses? Freezing temperatures in Europe, extreme weather across the world, shifting monsoons, and even an Amazon rainforest drying up. And the scariest part? Some researchers say there's a 95% chance this could happen before the end of the century. Think of the AMOC like a giant conveyor belt in the ocean. Warm, salty water from the tropics flows north towards Europe and North America. When it reaches colder areas, it cools down, becomes heavier, and sinks to the bottom of the ocean. This deep, cold water then moves southward, while fresh, warm water from the equator keeps flowing north to replace it. This system helps regulate global temperatures, keeps Europe's winters mild, and prevents the US East Coast from flooding. It also controls monsoon patterns that bring seasonal rain to parts of Africa, South America, and Asia. Without it, the world's climate would look completely different. Right now, melting ice from Greenland and Antarctica, along with increased rainfall and river runoff, is dumping too much fresh water into the North Atlantic. Since fresh water is lighter than seawater, it disrupts the sinking process that keeps the AMOC moving. If too much fresh water builds up, it will mess up the entire system. And once it collapses, there will be no reversing it, even if the climate later cools down. Scientists have seen two big warning signs. First of all, the warming of the ocean off the US East Coast, which suggests the AMOC is already slowing down. Plus, there's a cold blob of water south of Greenland. It might be a sign of the weakening of the ocean current, and that's exactly what happens before the system fails. What would happen if the AMOC fully shut down? Europe would enter an ice age. The AMOC plays an important role in keeping Europe's winters relatively mild by bringing warm water north. If this process stopped, Europe would be plunged into deep winter. London's climate would drop by 18 degrees Fahrenheit, making it feel like northern Canada. Stockholm could get up to 54 degrees Fahrenheit colder, turning it into Siberia-like conditions. And snow and ice would cover much of northern Europe year-round. Next, monsoons would shift, leading to severe droughts. The AMOC helps regulate tropical rainfall, especially in Africa, South America, and Asia. If it collapsed, West Africa's monsoons would shift or disappear, leading to devastating droughts and a massive food crisis. the Amazon rainforest could dry up, transforming into a savanna or grassland. In India and Southeast Asia, monsoon rains would disappear, and millions of people rely on them for agriculture. The U.S. East Coast could see catastrophic flooding. With the AMOC weakening, water is already piling up along the U.S. East Coast, triggering higher sea levels and stronger hurricanes. If the system shut down, sea levels would rise by up to 3.2 feet, which would make the coastal cities more vulnerable to flooding. Finally, hurricanes and extreme storms could become even more powerful because of warmer waters along the coast. Now, how close are we to disaster? For thousands of years, the AMOC has remained stable, but recent studies suggest it's weaker now than at any point in the past 1,600 years. Ocean temperatures are hitting record highs, and many researchers believe we are dangerously close to the tipping point. A study published in Nature claims that if greenhouse gas emissions continue at their current pace, there's a 95% chance that the AMOC will collapse before 2100.
A hole about the size of Switzerland or South Carolina keeps popping up in the Antarctic ice. This opening is growing steadily, and it took scientists half a century to figure out why. They found the answer with the help of seals. The scientists first spotted this gap, called Maud Rise Polynya, in the Weddell Sea in 1974. They were about to close the case as the hole disappeared, but it popped out again in the following 2 years, and then only in 2016. The giant hole is near Maud Rise, an underwater mountain. This type of hole is a Polynya, a rare patch of open water surrounded by thick sea ice. In Antarctica, when winter hits, the ocean surface freezes, and sea ice spreads out to cover an area about twice as big as the continental United States. Along the coast, openings in the sea ice pop up every year. This happens when powerful coastal winds blow off the continent and push the ice away. But it's a whole lot rarer for these openings to form way out over the open ocean, hundreds of miles from land, where the water is thousands of feet deep. Researchers from several universities teamed up to study the Maud Rise Polynya using computer models and satellite images. They even recruited some Antarctic seals to help out. These seals wore tiny helmets on their furry round heads with tracker sensors attached to them. Thanks to these sciencey seals, the team could collect water data from the source. After the research, the scientists discovered that the hole resulted from a complex mix of factors. The wind, ocean currents, and the special shape of the ocean floor all work together, moving heat and salt up to the surface. In science talk, this swirling movement is called an Ekman transport. Ekman transport is what happens when wind messes with the surface of the ocean. When the wind blows across the water, it creates friction that grabs onto the top layer and pulls it along. Thanks to the Coriolis effect, which comes from Earth's spinning, the moving water gets pushed at a 90-degree angle from the wind's direction. So, instead of the water going exactly where the wind is pushing it, it drifts off at an angle. Which way it turns depends on which half of the planet you're on. In the northern hemisphere, the water shifts clockwise from the wind direction, and in the southern hemisphere, it shifts counterclockwise. Now, Ekman transport turned out to be the missing piece of the puzzle in the case of the Maud Rise hole. It helped balance the salt levels and keep mixing salt and heat up to the ocean surface. But as the sea ice melts, the surface water becomes less salty, which should stop the mixing. So the scientists realized something else had to be happening to keep the Polynya open. There had to be another source of salt. Salt lowers the freezing point of water. To find out where this extra salt was coming from, the team dug back into their data and ran more computer models on the ocean. They found that swirling currents formed as the Weddell current flows around Maud Rise. These currents carry salt up to the top of the underwater mountain. From there, Ekman transport kicks in. As the top layer of water moves away with the wind, water from deeper down rises to take its place. At Maud Rise, this upwelling water brings along the extra salty water built up around the seamouth. and that's what helps keep the Polynya from freezing over. Scientists follow any changes in Antarctica as they influence the rest of the world. Researchers at Stanford University used machine learning for the first time to study detailed satellite data showing how ice moves in the polar region. They combined huge amounts of real-world data with physics rules to understand the Antarctic ice sheet better. It's the biggest ice mass on Earth, almost twice as large as Australia. It acts like a giant sponge for the planet, storing fresh water as ice and stabilizing sea levels. Scientists used to rely on models based on lab experiments, but real Antarctic ice is way more complex, with cracks, air pockets, and different types of ice that behave unpredictably. Instead of trying to model every little detail, the team trained a machine learning model using data from 2007 to 2018. It looked at 5 major ice shelves and created new models showing the ice's resistance to flow. They found that near the land, the ice is compressed and behaves as in lab predictions. But farther out, the ice is stretched toward the ocean and acts differently depending on direction. Less than 5% of the ice shelf is compressed. The other 95% behaves in a way old models didn't fully explain. This research could seriously improve our predictions of how Antarctica might change in the future. Another recent piece of big scientific news from Antarctica changes the history of birds as we know it. For a long time, it was simple. Dinosaurs ruled the Earth until an asteroid hit 66 million years ago and wiped them all out, except for some avian dinosaurs, which eventually became birds like eagles and chickens. Now, scientists have found a headless fossil of a VYI on Vega Island in Antarctica. The fossil was 68 million years old, at least 2 million years older than the asteroid strike. Without a skull, it was unclear what modern birds VYI might be related to, and guesses included waterfowl and shorebirds. Nearly 20 years later, another expedition found a bird's skull in Antarctica. After careful study, scientists matched it to VYI and concluded it was an ancestor of modern water birds like loons and grebes. If it's all true, VYI is now the oldest known modern bird in fossil records. The skull had a long, pointed beak, a brain unlike any other Mesozoic bird, and signs of strong jaw muscles like mine, which were perfect for diving underwater and catching fish. The body fossil also had adaptations for underwater swimming, similar to modern diving birds. During the late Cretaceous period, Antarctica was a temperate rainforest, far from the Yucatan, so it could have become a safe haven during the asteroid disaster. So, early modern birds might have survived there. When a giant iceberg, about the size of Chicago, broke off from Antarctica's massive ice shelf, scientists nearby did something no one had ever done before. They sailed straight over to check out the newly exposed seafloor. Studying the undersides of ice shelves is incredibly hard, but thanks to the iceberg A84, a 209 square mile patch of seafloor suddenly opened wide for exploration. The scientists deployed all their high-tech gear, including a remotely operated submersible and autonomous robots, to collect data about the seafloor and the properties of the water above it. Life exists almost everywhere in the ocean, from the bright, shallow waters to the pitch-black, volcanic deep sea. But the research team was really surprised to find such a diversity of life down there. They found a forest of sponges, giant sea spiders, ice fish, octopuses, huge corals, anemones, and even glowing deep-sea jellyfish. Normally, deep-sea creatures get their nutrients from organic matter falling from the ocean surface. But under a 500-foot thick sheet of ice that had been there for who knows how long, that wasn't possible. That meant the creatures had to be getting their nutrients in some completely different way. To figure out how long this hidden ecosystem had been around, the scientists studied the sea sponges. Sponges grow extremely slowly, only about an inch per year, but the ones they found were huge, so they must have been growing there for decades or even centuries. The team is hoping that the mountain of ocean and environmental data they collected during the expedition will help them understand how these ecosystems managed to thrive in those conditions and maybe reveal some completely new species that no one has ever seen before.
Hey, want to take a wild trip back in time to the Jurassic or Cambrian era? Trust me, it's going to be a wild ride, but surviving in those ancient environments would require some serious skills. At the start of the Cambrian era, the air would be as thin as at the base camp of Mount Everest, but the climate was actually pretty chill and consistent back then. However, there was one teeny tiny problem: no land plants or animals to feast on. So forget about firing up the grill for a juicy steak. Instead, you'd have to come up with creative ways to catch trilobites and other funky-looking shellfish. Good luck finding a spear without any wood or a fishing net without any plant fibers. And get ready to eat them raw, unless you can figure out how to extract oil from these creatures or burn dry seaweed. But wait, if you're looking for a more comfortable existence, you gotta travel to 100 million years ago, to the Silurian period. Here, things start to get a bit easier. The air is still thin, but there's a bit more oxygen to go around. Plus, the climate is warmer and cozier. Simple land plants have finally made their debut. Not only that, but the first bony fish also show up on the scene, so you might actually find something more palatable to munch on. Just watch out for those prehistoric millipedes and spider-like creatures that share the land with you. They might not be the best dinner companions. Yeah, it all sounds fun and feasible, but let's talk a bit more about this crazy idea of instant transportation. If you magically appeared in a different time, the first thing you'd have to worry about is the amount of oxygen in the air. Now, looking at that fancy graph up there, it's pretty clear that oxygen levels used to be super low before about 0.85 billion years ago. Like, we're talking just a few % of the atmosphere. And there wasn't even any O2 in the air until this event called the Great Oxygenation happened about 2.3 billion years ago. So if you ended up back then, surviving would totally depend on how fit you are. If the oxygen concentration was less than 10%, you'd probably pass out, but not pass away. If it was just above 10%, you might be able to function, but you wouldn't exactly be living your best life. Based on oxygen alone, it seems like you could survive if you showed up around 0.75 billion years ago, give or take a few million years. Now let's talk about the cool stuff on land. The first land plants didn't show up until around 450 million years ago during the Ordovician period. Before that, there were some large algae hanging around, mostly in the range of 500 to 600 million years ago. But there wasn't a whole lot going on until those land plants came along. Other forms of life didn't start showing up on land until closer to 300 to 400 million years ago. But there was this critter, a myriapod, that lived around 428 million years ago, and it was one of the earliest land dwellers. I mean, if you lived back then, you'd have to come up with fancy recipes featuring myriapods. Not exactly mouth-watering. Don't worry if you find yourself back in time before all that land action. Around 500 to 600 million years ago, the oceans were teeming with life. There were these creatures called the Edicarian fauna, and they were some of the first well-preserved organisms. Some of them probably hung out in the shallow areas near the shore, so you might be able to get your hands on them for a meal. But remember, there weren't any land plants yet, so you'd probably have to eat them raw and with no potatoes on the side. You'd have a sort of prehistoric sashimi on your plate. Now, around 500 million years ago, things started to get really interesting in the oceans after something called the Cambrian explosion. If you ended up in the Cambrian period, you'd have all sorts of weird animals to catch in the coastal zones. Check out the fossils from the Burgess Shale for some wild ideas. Look at these brachiopods, arthropods, and even worm-like critters. But again, no woody land plants at this point, so your meals would mostly consist of raw arthropods and algae. Alrighty, let's dive into the nitty-gritty of ice ages. It's when the Earth gets super chilly for a ridiculously long time, like millions and millions of years. This causes giant ice sheets and glaciers to spread all over the place, covering massive areas of the planet's surface. Believe it or not, our planet has experienced at least 5 major ice ages. The very first one happened about 2 billion years ago and lasted for 300 million years. The most recent ice age kicked off at around 2.6 million years ago, and we're technically still in it. So, we're in the middle of an ice age, but we're not currently living in an icy wonderland. That's because we're currently in an interglacial period. During an ice age, temperatures go through ups and downs. When it's warmer, those ice sheets and glaciers start to melt, creating what we call interglacials. And when it gets colder, they expand again, which we call glacials. So right now, we're enjoying the warm interglacial period of the most recent ice age, which kicked off around 11,000 years ago. When people mention the Ice Age, they're usually talking about the last glacial period that started around 115,000 years ago and ended roughly 11,000 years ago when our current interglacial period began. During that glacial period, things were way cooler than they are now. At its peak, when ice sheets covered most of North America, the average global temperature was about 46 degrees Fahrenheit. That's a whole 11 degrees Fahrenheit cooler than today's global average temperature. That temperature difference may not seem like much, but it was enough to turn most of North America and Eurasia into ice-covered landscapes. The Earth was also a lot drier, and sea levels were way lower because most of the water was trapped in those ice sheets. We're talking vast steppes, dry, grassy plains as far as the eye can see. And let's not forget about the savannas, warm, grassy plains, and deserts that were also part of the icy scene. During the Ice Age, there were some familiar critters roaming around, like brown bears, caribou, and wolves. But there were also some mega cool creatures that sadly went extinct when the Ice Age came to an end. We're talking mammoths, mastodons, saber-toothed cats, and giant ground sloths. Now, there are a bunch of theories floating around about why these magnificent beasts bit the dust. One idea is that us humans hunted them into extinction when we crossed paths with these megafauna. Our species, Homo sapiens, actually survived the Ice Age. We've been kicking it on this planet for around 300,000 years now, starting out in Africa and then spreading our awesomeness all over the globe. Some of our ancestors stayed put in Africa and didn't experience the full icy effects. Others ventured into different parts of the world, even braving the freezing cold of Europe's glacial environments. But we weren't the only ones out there. At the beginning of the Ice Age, there were other hominids, our closer relatives, scattered across Eurasia. We had the Neanderthals chilling in Europe, and the mysterious Denisovans hanging out in Asia. Sadly, both of these groups seems to have vanished before the Ice Age wrapped up. Now, there are countless theories about how our species managed to survive the Ice Age while our hominin buddies didn't make it. Some believe it's because we're ridiculously adaptable and used our social skills, communication, and nifty tools to our advantage. And get this, humans didn't just hunker down during the Ice Age. Nope, we explored new territories and made ourselves at home. For the longest time, folks thought humans didn't set foot in North America until after the ice sheets started melting. Fossilized footprints discovered at White Sands National Park in New Mexico prove that humans have been rocking it in North America for at least 23,000 years, right around the peak of the last ice age.
Did you know that the Pleistocene era was a really important time in Earth's history? It's when the last ice age happened, and glaciers covered a lot of the planet. This period of time lasted for about 2.6 million years, and ended around 11,700 years ago. What's even cooler is that modern humans, like us, had actually evolved during this time, and had spread all over Earth before it ended. There were also some really fascinating animals that lived during the Pleistocene, like woolly mammoths and saber-toothed cats. Unfortunately, many of them went extinct at the end of this era. Earth has had some pretty wild weather patterns over the last 2.4 billion years. Although the planet is mostly ice-free, we now cycle in and out of freezing ice ages. During these glacial periods, temperatures drop, and huge areas of the planet get covered in ice. It all starts with a bit of snow, which then builds up over time. The ice reflects sunlight, making things even cooler. The result? Vast glaciers that slowly move toward the equator, changing the landscape as they go. And when the ice melts, sea levels rise again, and everything changes all over again. In total, there have been at least 5 ice ages so far. The first one was so intense that the whole planet turned into a huge snowball. Right now, we're actually in the middle of an ice age, but we're currently in a temporary warm spell that started around 11,000 years ago. These warm periods are called interglacials, and we're not quite sure how long they last. There are still massive ice sheets covering Antarctica and Greenland that hold 75% of Earth's fresh water. When these finally melt, it'll mark the end of the current ice age. Earth's temperature is affected by something called the Milankovitch cycles. Basically, the amount of heat we receive from the sun changes over years, decades, and millennia because of Earth's orbit, tilt, and axis angle. There are 3 different patterns to these cycles. The first is called eccentricity, which is all about the shape of our orbit. The second is obliquity, which has to do with the tilt of the Earth. And the third is precession, which is like a wobble as Earth spins. Depending on where we are in these cycles, we might experience colder or warmer temperatures. But other things, like the position of continents and the atmosphere, also play a role in our planet's fate. For example, our planet's orbit is not quite circular. It's actually a bit elongated, shaped almost like an egg. That means we're sometimes a little closer or farther from the sun, depending on the time of year. We call the point farthest away from the sun the apogee, and the closest point is the perigee. When we're at the apogee, we're moving away from the sun, but gravity eventually pulls us back toward it. This means our orbit changes a little each time, gradually shifting our position relative to the sun. Don't worry, even though the orbit changes over thousands of years, it doesn't have a big impact on our day-to-day lives. Changes in Earth's orbit can affect how much sunlight we get during the summer. This means that ice sheets in the northern hemisphere will melt less, and over time, they actually start to grow. As they grow, they reflect even more sunlight, which makes the climate even cooler and spreads the ice even farther. This process can last for a really long time, like 10,000 to 20,000 years, and eventually it brings the planet into its next freezing season. As for the next ice age, scientists believe it might be postponed indefinitely. They've found that our human interaction with the environment, like the use of fuels, could delay the next ice age by up to 100,000 years. Earth's past ice ages were linked to the amount of solar radiation and carbon dioxide concentration in the atmosphere, and this research can even help us predict future cycles. It's amazing to think that our actions now could affect Earth's future for thousands of years to come. And while it's not really important when the next ice age begins, it's pretty cool to know that humans have the power to shape the future on a geological timescale. Ice ages have had a huge impact on our planet and human civilization. So it's fascinating to think how our actions now might change things, maybe even for the better. What did life look like on our planet during the last ice age, though? Well, North America, for instance, was home to some huge creatures. Mammoths, saber-toothed cats, giant ground sloths, and mastodons were just a few of them. And get this, even Europe had an 11-foot tall flightless bird that weighed almost as much as a polar bear. Meanwhile, down under in Australia, there was a giant lizard that lived in all sorts of habitats during the same time period. Even though some animals from the Pleistocene era aren't around anymore, you might recognize many of those that are still around today. In Alaska, for example, you can still find brown bears, caribou, and wolves. People just like us actually lived through the Ice Age too. Our species, Homo sapiens, has been around for about 300,000 years. And we've spread all around the world since then. Some of our ancestors stayed in Africa during the Ice Age and didn't feel the full effects of the cold. And others ventured out into other parts of the world, even into the chilly glacial environments of Europe. Our early relatives, like the Neanderthals in Europe, and the mysterious Denisovians in Asia, were also around during this time. Although they seem to have gone extinct before the end of the Ice Age, it's pretty amazing to think about all those different hominids that roamed Earth during that period. What's also fascinating is how our species managed to survive the Ice Age, while some of our cousins didn't. Some experts believe that our adaptability, social and communication skills, and the use of tools played a huge role in it. And guess what? Humans didn't just hunker down during that time. We actually moved into new areas. Fossilized footprints found at White Sands National Park in New Mexico prove that humans have been in North America since at least 23,000 years ago. That's close to the peak of the last Ice Age. While a full-blown Ice Age might still be far away, there is a possibility of a mini Ice Age coming our way. Some scientists believe that in about 10 years, we might experience a significant drop in solar activity, leading to colder temperatures in the northern hemisphere. This could result in conditions similar to the Little Ice Age in the late 17th century, when the Thames River in the UK froze over. While scientists aren't quite sure what caused that cooling, it's fascinating to think about the potential changes. We've done it before, so we know that humans will most likely survive the next real Ice Age, even if we don't manage to figure out a way to stop the next freezing era. But it would come at a high cost. All the ice that would cover most of the northern hemisphere would have to come from oceans, which would cause the sea level to drop. This could mean more land for some countries, but it would also create other problems. Sea levels going down might seem like a great thing at first, but actually, it could lead to some challenges. Having been covered with salt water for thousands of years, the new land might not be very fertile. This means it wouldn't be great for growing crops, and we'd have to find other ways to feed ourselves. Back when humans first started out, there weren't many of us, and there was plenty of food. Now, with over 7 billion people on the planet, it's a different story. We'll need to be resourceful to make sure everyone has enough food to eat.
Discovering hidden places on our planet is extremely exciting. Today, I'm taking you on a trip that you aren't going to forget anytime soon. But suit up, this is about to get very cold. You hop on a plane and land on the ice-covered island of Greenland. An unbelievable view of the Aurora Borealis, aka the Northern Lights, is greeting you. You can't believe your eyes. Your guide tells you how rare this phenomenon is. Usually, people spend days trying to hunt it down. You feel lucky and take your time to appreciate these beautiful dancing greenish lights. You're glad you brought your camera along, aren't you? Between clicks, you learn that the Aurora Borealis is the result of some rather rough events. This spectacular light show occurs when energy particles from the sun slam into Earth's upper atmosphere. On day 2, you continue to explore the place by air. This may not come as a surprise, but Greenland is one of the world's largest islands. This time, on board a helicopter, you can see the infinite icy landscape. In case you're curious, you're now flying over 656,000 square miles of thick ice. Oh, what's that down there? It looks like a family of polar bears. You don't want to get too close, of course. The conditions in Greenland might be too tough for people to live there, but some animal species do very well in this land of ice. Those are reindeer, wolves, and Arctic foxes. On your way to Greenland, you probably made a pit stop in Copenhagen. Denmark is one of the few countries that have commercial flights to Greenland. You didn't know this before, but you find out that the island is actually part of the Kingdom of Denmark. On a map, it's right between the Arctic and Atlantic Oceans. You're lucky to have a local pilot that tells you about the secrets hidden in this scenery. Under this 2-mile thick white surface, there's an entirely different world. A world filled with canyons, meteor-carved craters, and millennia-old plant fossils. You are beyond excited to go visit one of these spots, but of course, you'll have to use your imagination, as all of it is hidden under ice. Believe it or not, nearly 80% of the island's surface is covered with it. The first stop on your tour is Greenland's Grand Canyon. You land not far from it, somewhere in the northern part of the island. You may know that canyons are deep, narrow valleys with steep sides, but I bet you didn't know that the word canyon actually comes from the Spanish word cañón, which means tube or pipe. Now, this Grand Canyon has some similarities with the one in the US. First of all, in size. It's at least 460 miles long and up to 2,600 feet deep in some places. There's a true subglacial valley down there, and if you're wondering how this happened, well, the canyon had probably been formed by a river that had been flowing through Greenland before the ice took over. Oh yeah, Greenland hasn't always been covered with ice. It was once green, no pun intended. Many other icy places on Earth, such as Antarctica, were once covered in greenery. Scientists have figured out that in the past, Greenland was mostly ice-free. With the help of airborne radar, they made amazing discoveries. By the way, ice is invisible to radar technology. If you have trouble believing it, try putting an ice cube inside your microwave. It won't melt or heat up. A recent discovery of fossilized plants allowed researchers to estimate that Greenland used to be much warmer than they could imagine. 2021 research conducted by the University of Vermont found fossils of twigs and leaves, which left researchers very confused. They expected to discover sand and rocks in the deepest layer of ice, but instead, they found some clear proof of rich flora. Judging by what you've seen of the landscape, it's hard to believe that forests were once growing here. Today, you'll find some tundra vegetation on the coastal part of the island, and that's pretty much it. But according to the genetic material found in these fossilized plants, researchers believe the island used to be much greener. It's very likely that there were insect-filled forests with butterflies and beetles flying around, and the average temperature on the island varied from 50 degrees Fahrenheit in the summer to 1 degrees Fahrenheit in the winter. NASA's Operation Ice Bridge has flown over Greenland more than 100 times. This has allowed researchers to create 3D maps of the island and figure out the age of each layer of ice in Greenland's ice sheet. Ice sheets can help answer many scientific questions as they form over the span of thousands of years. They're layers of snow on top of more snow. The snow gets compacted into ice, which in turn creates what we call an ice sheet. Remember those fossils we were talking about? They're believed to be from the Eemian period, which was 130,000 to 115,000 years ago. According to the groundbreaking 3D footage from NASA, we can see 3 distinct climate periods within the ice sheet. The uppermost layer is quite flat and uniform. If you decided to dig deeper, you'd find the layer formed during the last ice age. It's more complex and rugged. The ice there is darker than what you see on the surface. If you let your mind wander, you can picture what this part of the world looked like when mammoths were roaming around. If you kept digging, you'd eventually find leftover ice from the Eemian period I've told you about. Now, canyons aren't the only unusual thing found under ice. If you could sneak a peek under all those layers of snow, you'd see an impressive mountain range and also plunging fjords. In 2017, scientists created a map that showed what Greenland had looked like without all that ice. There was a bowl-like depression in the middle of the enormous island. This depression was most likely an ancient lake. Around it, there was a circle of coastal mountain ranges. This scenery probably resembled the landscapes of modern Patagonia. Big mountains with snowy tops surrounding crystalline lakes. This ancient lake in Greenland is a wonder on its own. Imagine a pit the size of Rhode Island and Delaware put together. The lake is believed to have covered over 2,700 square miles, and back in the day, it was fed by at least 18 different streams. These crystalline blue waters were surely very inviting, and freezing of course. But if you ended up going for a swim, I'd say be careful, as the water could get up to 800 feet deep in some places. On day 3 of your adventure, you discover a true under-ice water park. While you're wandering around the ice-covered island, your guide tells you to be mindful of the cracks in the surface. These cracks are responsible for the modern-day aqua lounge going on down there. Meltwater and rainwater flow down the cracks in the ice all the way down to the riverbeds. This forms a landscape of jewel-like lakes and streams filled with crystalline water. Researchers estimate that about 60 small under-ice lakes exist there. And yes, they're actual lakes. Perhaps one of the most impressive hidden features on this island is a meteor crater. Under the Hiawatha Glacier, you can find a 19-mile-wide impact crater big enough to swallow the city of Washington. Apparently, a mile-wide iron asteroid struck Earth's atmosphere within the past 100,000 years and chose Greenland as its landing point. If anyone had been around to see it, they'd have witnessed a real show, a white glowing fireball cutting through the sky. Scientists speculate that if it had landed on an ice sheet, it certainly vaporized both water and stone. Someone standing hundreds of miles from the impact site would have heard a deafening thunderclap and experienced hurricane-force winds. But it actually makes sense. The approximate speed of meteors entering Earth's atmosphere is 45,000 miles per hour. For comparison, that is 2.5 times the speed of a spaceship. It's bound to make some noise and leave a huge crater in the ground.